This video is going to be about random numbers in Java specifically. My last video talked about what random numbers are and what are some of the limitations of the random number generators in popular programming languages. So in this video, I'll focus on the practical uses of random number generators. So let's try to dive into that. So I already created a small application here with just a simple main method and nothing else. So I can run this application here and it won't do anything really. So let me just create a print line to say hello and we'll get going. So in Java, we have different kinds of ways we can get random numbers. The most obvious one is the math, which is part of the Java lang, so we don't need to import it, and just called random. This is one of them. There is also another one called random, and I think it's under Java util random. And this is a class that we can use for generating random numbers, so we can make instances of it. And there is also another one that is called thread local random. And this one is used for, and I think it's under Java concurrent. This is used for some optimizations when you need random numbers in multi-threaded applications. So I'm not going to go into that. I don't think it's very relevant right now unless you're doing performance critical multi-threaded applications. So I'm going to skip that. It's just if you see that somewhere, then this is it is there, but you should only use it if you're using multiple threads and you're having performance issues. Then the last one is I want to show is secure random. And secure random is for cryptographically safe random numbers. So as I've shown you in the previous video I did, the random numbers that are generated are not really random. We can clearly see some patterns here also for Java. So we need something else if we're going to generate secure. I'm not going to go deep into that because it's only used for cryptography, but I just want to mention it briefly because it's something you would want to know about. Okay, so first off, let's look into math random. So if I write math and then random, I can see that I get a double. So that means that that is the only thing I can get from a math random. I get a double. And what does it really look like? That could be interesting. So let's put this in a variable, like let's call this x, or maybe let's call it r instead. And then we're going to print out the random number. So I'm writing random number, colon, and then the number. And Java will convert that into string automatically and display it on the screen. So now we get a number 0.4777 something. If I do it again, it should be different. Yeah, 0.38. Do it again. Do it again. And you probably noticed something here. Let's try to put this into a loop. So now I created a for loop. Let's do this like 10 times and print it out. And now, of course, we will get the same number. Let's see. So we would want it to be random each time. We'll put it in here. Okay, so now we get a different kinds of random numbers here. So if you look into this, you will see that the more you do this, there is certainly one pattern to this number, and that is it's always less than 1 and it's always bigger than 0. Right? These numbers are between 0 and 1. It's always. So this is a number between 0 and 1. So what can we use this for? So the reason why it's a number between 0 and 1 is because that is really what comes out of these number generators. If we look into this algorithm here, this will generate some numbers between 0 and 1. So this is why it's a number between 0 and 1. And it's really easy to use. So let's say that I want another number. So right now it's a number between 0 and 1. What if I want a number between 0 and 10, for example? So if I say r equals r multiplied by 10, what happens then? So now we're getting numbers that are between 0 and 10 instead, just by multiplying by 10. And if I want it between 0 and 100, I can, of course, just multiply by 100. What if I want a number between 0 and 5? What would happen if I wrote 5 here instead? Wow. So if we want a number between something, we can just multiply by 5. So what if I want a number between 5 and 10? Yeah, that's also really easy. We just add 5 to the number. So the smallest number will be 0 and the biggest number will be 10 because this part is between 0 and 5 and this part is always 5. So we add 5 to 0, it's 5, and we add 5 to 5, then it's 10. So this will be between 5 and 10. Let's try that. Okay. And we see this is just over 5, this is just below 10. So this looks pretty easy. So why is it 5 here? Because it was between 5 and 10. What if I wanted between 5 and 100? If I type 100 here, let's see what's going on. I see that now I'm getting, oh, sorry. So we see now I'm getting, this was of course between, if I wanted between 100 and 105. So I need to kind of know that the top of this is going to be 5 plus 100, right? So it's really this number and this number that sets the top. So this was just to show you how can we generate numbers like this, and if we wanted to change it into something like an int, we could say I equals R, and we'll get some problems because it cannot, R cannot just be put into an int because it can be too large, and there's a lot of stuff going on. So we can kind of convert that, and the easiest way is just to typecast it like this. Oh, I forgot I used I up here, so I better change this into something like K, and we'll use K here instead. So now it just removes everything behind the first number. So it doesn't round it really, it just takes a number. So if we go back between 5 and 10, we should see numbers between 5 and 10. Oh yeah, 5 and 10, like this. And you see 10 is not really included here. So now we are really getting numbers between 5 and 9. So we could just add one more here. And now we get between 5 and 10. Okay, so this way we can generate random numbers of any kind from the math random. So this is really a way to go for math random. So let's just go write math random number so that we remember that that's it. So let me just outcomment this for a second. So this was for the math random. So sometimes it's impractical to do these calculations. You see, I even confused myself a couple of times while doing this. So we can use the random class for that. So if we use the random class instead, we have to type random. And if we see, we have it's in Java util. So I was correct up here. And I import that, and random, we call it rand equals new. And of course, we need to initialize the random generator. And let's do something interesting. Let's copy the code from up here and say we want to do the same thing, but this time, let's see what we can do with random. So if I type rand, which is the random generator now, we can see we can actually get by typing next, we can get a Boolean, we can get a byte, we can get double, we can get float, Gaussian, int, long, we can get a lot of cool stuff. So now we don't need to use something like these weird calculations. We can just get integers right off the bat. So instead of using this part here, my int k, I can just say rand and then just next int. So this will just give me some random integer. Let's see. And these are really random, right? Like from the lowest int possible to the highest int possible. And we can put a bound here. So if I type 10, it will go from 1 from 0 and actually up until 9. So we shouldn't get a 10 here. Not even a 9 yet. Oh, there's 1 9 here, but we won't get 10. So we need to add one more if we want from 0 to 10. We need to go and add one more here. And still, if we wanted to go from a lower bound or something like that, there isn't anything for that if we look at the next int method in the ran. There's only either get total random int or we can get the bound one. So we can't go for a lower bound. So we could create a method for that. If we want a lower bound, we can just add a number here, which will then be the lower bound. So if I put 1 here, 1 will then be the lowest, and in this case, 10 will be the highest one. So we still need to do some calculations if we want that. Yeah, and we can get other things like random booleans and stuff like that. But you can probably imagine we could have created all of this from math random. So this is one of the differences that are interesting. So there's another interesting difference here, and that is, and you've probably been wondering this, and that is, what is the seed? So we see that each time that I run this, it's seemingly random. The numbers are different each and every time. And because we know how we generate random numbers, that we have to have a seed, we have to have a starting number. So what we can't see here is that this random method here from Java util actually uses some magic to generate random numbers each time. You can do this in different ways. I'm not going into the details. You can actually look it up. It's very well documented within the Java documentation how to do this. But if you look it up, it's a bit more to it. But basically, what most programs do is they use time. So they take the time right now, for example, the number of milliseconds that has passed since the 1st of January 1970 or something like that. So that means that this random number, row of random numbers, will actually change each time because time changes. You can utilize other things if you have them available. So it can also use something else for seeding. For example, the MAC address of the computer, which will be unique for each and every network interface card. If it does have a MAC address, it can't be sure to have that, so it probably won't use that. And you can use other things as well. I've seen some people using static noise from the outside or something like that for generating random numbers. Lava lamps with lasers and everything like that. There's a lot of ways to get some randomness into it. So in this case, it uses the time of the computer along with some maths, and you can go look it up if you want to. I'm not going into details with that. So that means that it is actually using an invisible seed. We can put our own seed in here. This is part of the Java random. We can seed type seed here. And now I will get some other random numbers. The interesting thing now is I use this seed, I'll get the same row of random numbers again and again. So now they won't change between executions of the program because they're using the same seed. So if I would fetch the time, it would change for this. Yeah. So an important thing to notice when doing this is now we're creating an instance based on the seed. So we have to use the same instance each time in order to get the next number in the row. So the algorithm for generating random numbers is based on the seed at first, and then the next number, and then the next random number is based on the last random number. So that also means that if I move this into our loop, then I will be creating 10 random number generators and getting the first number of that. So if we look here, we can see we get the exact same number because if I move it back again, sorry, if I move it back out here, 2 is the first number when we start with 1337. 2 is the first number in this row. So we have to be careful with that. So what then if we put we don't put the random number in here? We could get into problems. So let's try to do that. So it doesn't look like it creates any problems here, but I'm not sure if it does actually. So I've seen before, so generally the problem is that we might see, like here we have 10 and 10, and we might have more of that because of the way that we use time for seeds. So if you imagine that this is some point in time, this for loop will go very, very fast. And I think the only reason why we're not getting more problems is because it has to type it out here to the screen because this is quite slow, this here. So the problem is if we put random in here, we'll get the first random number based on the time seed. So let's say that the first time seed is 1, and then the next one is 2, and the next one is 3. If this all goes on within the same nanosecond or millisecond, it's really fast, then we would get it based on the same seed every time. So let me just skip time for a second and show you something. So now I just changed everything. I skipped time a bit, not to use too much of the video time on this, but I changed it into actually adding it into an array list instead and then printing it out. And it seems that they kind of fixed the problem with having the random within the loop. So I don't know, they changed something around earlier in Java. This would be a problem. So, but still the best thing would be to put it outside here. So I think I'll just go back to the old one. I just wanted to check if this was still true, but it looks like they actually fixed it so that you won't get the same number each time. Yeah. So I'll just skip time and go back. So now we're back to the old code and the correct way of putting the random outside of the loop, because we don't want a new random generator for each number that we generate. We want one, and then we want to put in some kind of seed or anything like that here, or we can use the Java's own seed so that we get something different each time. So you could ask yourself the question, why would we want to have something like a seed? And the simple answer is for repeatability. So sometimes if you want to test out something, it's nice to have the same problem occurring again and again. So if, for example, you're testing your game or something, then if the randomness is not really random, but the same thing happens over and over, then you can retest it and fix the problem, retest, fix the problem, and this way you will figure out some solution to that problem. If you get real random numbers each time, it might not work that well. An example of that using randomness is the game Minecraft. If you tried Minecraft, it's really cool. You'll see that with the same, they also use these seeds, which are really just because they're using the same random number generator, the same instance of the random number generator with the same seed for generating the entire level that you're playing, which is really an endless procedurally generated world, which is not really endless in the game because there are limits to how much you can save, but algorithmic or programmatically wise, we could create an endless world from a single seed. So in Minecraft, we can create a new world. And when we create a new world, it will ask for a seed, and that seed will use Java util random for generating the entire world. And that also means if you look up on the web, you can find other people's cool seeds. So you can look these up and you can find an entire world of fun just from a single seed. So it's kind of interesting. So now I generated in the examples that I've shown, I've generated something really simple like this image here from the random numbers. But in Minecraft, they generate an entire world complete with monsters and houses, villages, mountains, different kinds of landscapes, all this kinds of stuff by starting out with a single number. And it's quite brilliant because it makes almost unlimited amount of worlds. All the seeds that exist can create a new world. So this way, Minecraft is pretty wild, I think, that we use random like that. So by single instance, we can create all the numbers that we need and want. Yeah. So yeah, so this is one way they use the seed, and this is what we were coming from. They use the seed for generating the same world over and over again on or even different computers because they use the same algorithm for creating the world, and that's based on randomness. So it's seemingly random, but really it's not random at all. It's all based on the same seed. So when you create a new Minecraft world, it will probably just take the time of your computer and feed it into it. So the entire world is based on that instance in time. Yes, so that was the biggest part of this video, to explain that and explain how the um, random generator works. So then we have two small things left I want to talk about. One of them is the thread local random. I'm not going into that. It's part of, if you want, instead of using math random or this random class, if you're using threads, multi-threaded for multiple processes running at the same time, you would need to use this for, this is just for speed, so it's not that interesting. So secure random, I think, is a bit more interesting. So because some of these security algorithms are actually based on random numbers, and in order for them to be safe, no one can actually get the seed and then just guess everything. We have this under Java util, Java security, called secure random, and it's actually the same. It uses random, so it extends random, so it has some of the same methods. So this way we can generate secure random numbers. So you need that. So if you're ever involved in anything that needs secure and real random numbers, you need to use secure random number generators and not a linear congruential number generators. So basically you can do some of the same stuff. So if we go secure random, and then say ran2, then we can see that we have different things, but also it has special things like algorithms for actually generating the algorithms. So if we do something like this, string s equals, and then just print that. And I'll just disable this part for a second. Play. We can see that it uses something called DRBG as the default algorithm for secure random. Other than that, it should have the same method as it extends, so we can say ran2 get, or sorry, next. We can go next int and we can get the same numbers and they will just be more secure. Of course, it will also be slower. This is one of the reasons why they still use these sequential generators, because they are really fast to use. So most of the time it will be fine and it will look random to anyone that actually uses them. So if you're doing a card game, you don't need secure random schemes, except if you're if it's a poker game with money involved, maybe you would want to have something a bit more secure. And you can also find websites. There's actually people that are involved in creating random numbers. So if I go search for random, you'd see there is random.org, which actually is a service where you can get true randomness. You can actually pay for this. There's some free stuff in here, but you can actually pay to get real random numbers. And this guy in here is really, he cares about real random numbers. You can go in here and read a lot of stuff about it. It's really interesting. Yeah, so that's it for random numbers, something seemingly simple that's not that simple when you look a bit deeper into it. So that's it. Bye.